Imagine a world where we could predict and prepare for the sun's most destructive tantrums. That's exactly what the European Space Agency's ESA solar orbiter is working towards. But here's where it gets fascinating. This mission isn't just about observing the sun. It's about unraveling the mysteries behind two of its most powerful phenomena: solar flares and coronal mass ejections, CMEs. These events, while awe-inspiring, can wreak havoc on our spacecraft and even impact life on Earth. So, how does the solar orbiter help? It's all about distinguishing between these two types of solar outbursts, a task that's proven to be both critical and complex. The solar orbiter has made a groundbreaking discovery by categorizing the flood of particles ejected by the sun into two distinct groups. One group is linked to intense solar flares, while the other is associated with CMEs. And this is the part most people miss. CMEs, packed with high-energy particles, are particularly dangerous to spacecraft. Being able to quickly differentiate between these events is crucial for accurate space weather forecasting. But why is this so challenging? Scientists have long known about these solar energetic electron (SEE) events, but pinpointing their origins and behaviors has remained elusive until now. Thanks to the solar orbiter's unique ability to observe the sun from various distances using multiple instruments, researchers like Alexander Wormuth from the Leibniz Institute for Astrophysics Potsdam have made significant strides. Wormuth explains, by observing hundreds of events at different distances, we've been able to identify and understand these two groups in ways never before possible. The probe's close proximity to the sun allows it to measure particles in their early, pristine state, providing invaluable insights into when and where they originate. But here's the controversial part. One of the biggest puzzles for researchers is the apparent delay between when an SEE is observed on the sun and when the electrons are actually released. In some cases, this lag can last for hours. ESA research fellow Laura Rodriguez Garcia sheds light on this phenomenon, suggesting that it's not just a delay in release, but also in detection. Electrons encounter turbulence and scatter in different directions as they travel through space, she explains. These effects become more pronounced as you move farther from the sun, making immediate detection challenging. This work, published in Astronomy Astrophysics, is more than just academic. It has practical implications. Daniel Miller, ESA project scientist for Solar Orbiter, emphasizes, understanding these energetic particles from the sun is crucial for protecting our astronauts and satellites. Launched in 2020, the Solar Orbiter has already observed numerous CE events, creating a unique database for global research. Its findings will be further built upon by ESA's Vigil mission, set to launch in 2031, which aims to detect hazardous solar events before they become visible from Earth. Now here's a thought-provoking question. As we continue to unravel the sun's secrets, how will this knowledge shape our approach to space exploration and technology? Will we be able to predict and mitigate the impacts of CMEs before they reach us? Share your thoughts in the comments. Let's spark a discussion.